discuss the formation of geostrophic winds. Discuss the formation of geostrophic winds. Okay, that's one. And we continue with how is the geostrophic balance affected in gradient winds. In gradient winds. So how do you write this answer? You have an introduction. So you explain what is geostrophic winds. So geostrophic winds, these are a type of winds under conditions of balance. Okay, these are very high speed winds above the friction layers. So friction layers कितना होता है? 500 meters to 1000 meter and above, or 200 millibar pressure. You are right. Okay. So what are geostrophic winds? They're special type of winds under conditions of balance, under conditions of geostrophic balance, the high speed winds above the friction layer. Okay. And you can mention that these are parallel to the isobars. They're parallel to the isobars. They are isobars. These are westerly winds. These are westerly, they're upper tropospheric westerly winds. Okay, so you can explain this. Now you tell me, how are these upper tropospheric westerlies formed? Okay, क्या लिखेंगे आप? What are the 3 points here? How are the upper tropospheric westerly winds formed? They are formed because of, number one, there is a strong equator to poles pressure gradient. There is a strong equator to poles pressure gradient. That is one. Very high speeds and pressure gradient force balances the Coriolis force. You know this. Third, okay, they are formed at the junctions of the vertical meridional cells. I presume you understand this. They are because of strong equator to poles pressure gradient. They are high speed winds where the pressure gradient balances the Coriolis force. And third is at the junctions of the vertical meridional cells. Anybody knows what do I mean by this? And what are such winds called as? What do we call them as? There's one more term. They're also called as thermal winds. Have you heard this term? They're also called as thermal winds, not thermal induced. They're called as thermal winds. Why thermal winds? That difference in the gradient of temperature through the heights can create a horizontal pressure difference. Okay, what are thermal winds? Difference in the gradient of temperature through the heights can create an horizontal pressure difference. So what we have is this. So we have got two columns of air, column A, and we have another column B. Column A is warm air, column B is relatively cooler air. So the amount of air with height will reduce faster in the cooler air. Okay, so warm air hai, the air tends to spread in the vertical direction. So think of that this box has 100 molecules of air. So maybe I'll have maybe 20, 30 molecules here, 10, 15 molecules here, and 5 or 6 molecules here. This is cold, warm air. The air tends to spread. In the cold air, the air tends to sink down. So in this part, there is much lesser air compared to the air here. When explaining the geostrophic winds, you must talk about thermal winds. Okay, so there's warm air. The warm air could be the tropical air. Cooler air, this could be the mid-latitude air. In the warm air, the air spreads. So if you compare two heights, the amount of air here is more than the amount of air here. Surface maybe there is not much difference, but as we go up, okay, there is difference of the amount of molecules here. So with height, what happens is there is a strong pressure gradient. So in this column, the air here will have a higher pressure compared to the air here. This is at the margins of the meridional cells. So surface of the earth, this is equator, this is the poles. Air is rising, air is rising, air is sinking, air is sinking. Okay, air is rising, air is sinking. So if you look at this air, this is the Hadley cell. If you look at this air, is the Ferrel cell. If you look at this air, the polar cell. This air is the warmest. This air is cool. This is very, very cold. So the pressure here is more than the pressure here. The pressure here is more than the pressure here. This is high pressure, low pressure. High pressure, low pressure. To appreciate this, you must go back to this diagram. In the warm air, there is more air. In the cold column, there is less air. So more air, high pressure, less air, low pressure. So compare this with this one here. So in this column, this is relatively warmer, and this warmer air will have more pressure than this air. This relatively warmer air, between this and this is the warmer air. This will have more pressure than this one. And that is how we have an additional pressure gradient here, an additional pressure gradient here that creates the jet streams, This is the subtropical westerly jet stream. This is the polar jet stream. So I am discussing how are geostrophic winds formed. The geostrophic winds are formed when there is a very high pressure gradient in the upper troposphere. So what creates the pressure gradient? The pressure gradients are created because of this condition is called as thermal wind condition. Remember, thermal wind is not a type of a wind. Thermal wind is a condition of wind shearing. Remember this. The thermal wind is a condition of wind shearing because of difference in the temperatures of vertical air columns. Remember this. What are thermal winds? Thermal winds are a condition of wind shearing because of difference in temperature of the vertical air columns. So how are geostrophic winds created? The geostrophic winds are created because of, now these are the three conditions, because strong equator to polar pressure gradient, because of high speeds, okay, and the pressure gradient balance at the junctions of the vertical meridional cells. So this is what is the thermal wind condition. discuss how geostrophic winds are formed. Having said this, now you can draw the diagram. So in the geostrophic winds, okay, so now you can draw the diagram. We have the pressure gradient force, we have the Coriolis force. This is the wind direction. Okay, the winds move perpendicular to the pressure gradient force. This is parallel to the isobars. They're called wind shearing because the wind here is not same as the wind here, is not same as the wind here, is not same as the wind here. Okay, so these are layers of winds. And by the time you come here, the layer is very different. Okay, here the wind has entirely turned like this. So between the layers, there is different levels of turning, right up to here. So you can find shearing between the layers here. This is not much of gradient, a bit more of gradient, and very high gradient. So layers will vary. That's why they're called as conditions of wind shearing. Okay. How are the upper tropospheric westerlies formed? How are the geostrophic winds formed? Strong equator to polar pressure gradient, high speeds, and above the friction layer. Okay, and the junctions of the vertical meridional cells. And this is what creates the jet streams. Okay, so we'll move on here. Then what we have is you can have a small table, the types of geostrophic winds. You can talk about the jet streams, and what are the cause. You can talk about the upper tropospheric westerlies. You can talk about the TEJ in particular. All these are examples of the upper tropospheric geostrophic winds. Then you can talk about what are gradient winds. So gradient winds mein what happens is that the low pressure or the high pressure is localized. It is localized. The isobars are closed loops. These are closed loops. Therefore, the pressure gradient force is radial. So what happens in this is there is an additional centrifugal force. There's an additional centrifugal force. Okay. So one is there is a low pressure. And the second is there is a high pressure. In the high pressure, this is the PGF. In the low pressure, this is the PGF. Always the Coriolis force is opposite. The Coriolis force is always opposite. Because it is circular, there will always be a centrifugal force like this. There's always a centrifugal force. There is a centrifugal force. Okay, this is the low pressure. This is the high pressure. Okay, the PGF is from high towards low. The PGF, this is the PGF. PGF is from high towards low. Okay, this PGF is balanced by the Coriolis force. It is balanced by the Coriolis force. And an additional force is the centrifugal force. An additional force is centrifugal force. So in this case, what happens is the PGF and the centrifugal force are opposite. इसमें क्या होता है? The PGF and the centrifugal force are opposite, and therefore the centrifugal force weakens the PGF. इसमें क्या है? The PGF and the centrifugal force are in the same direction. So PGF is like this, the centrifugal force also like this. इसमें क्या है? The PGF is like this, the centrifugal force is in the opposite direction. So when the PGF is weakened, we have what's called as a subgeostrophic wind. This happens in the cyclones. And in this case, okay, this is an example of a super geostrophic wind. This happens in anticyclones. The super or sub, this is in the context of whether the centrifugal force is strengthening the PGF or it is weakening the PGF. So this is good enough for a short note on how does the gradient wind modify the geostrophic wind. This is two conditions. I have a low pressure. This is the low pressure. This is the high pressure. The direction of the PGF kya hoga? It's from high towards low. Okay, PGF. This is a high pressure and the outside is the low pressure. The direction of PGF kaisa hoga? PGF is what? Pressure gradient force. The PGF is always from high towards low. It's always high towards low. And the Coriolis force is always in the opposite direction. It's always in the opposite direction. So just to differentiate this I call as the Coriolis force. This is the Coriolis force. If it is a circular one, the winds are rotating, you always have an additional centrifugal force. You always have an additional centrifugal force. So this is the PGF force. This is the Coriolis force. And this is the centrifugal force. This is the PGF force. This is the Coriolis force. This is the centrifugal force. Okay, so in this case, what happens is the PGF force is opposite to centrifugal force. In this case, the PGF is aligned with the centrifugal force. देखो, PGF भी ऐसा है, centrifugal भी ऐसा है. इसमें क्या है? The PGF is like this, the centrifugal force is like this. So in this case, the PGF and centrifugal are opposite direction. They're in the same direction. You don't talk in the centripetal force, you talk in the context of the centrifugal force. So this is called as subgeostrophic. This is happening when? In the cyclones. And this is called as the super geostrophic. This happens when? In the anticyclones. If you want to look up the diagram, look up page number 91. Page number 90 and 91. So this is an example of a high pressure anticyclone from high towards low. This is the PGF. Okay. And a centrifugal force also. So this is an example of the PGF is strengthened by the centrifugal force. CEF is centrifugal force. PGF is pressure gradient force. This is super geostrophic. इसमें उल्टा हो रहा है. The centrifugal force is outside. The PGF is towards inside. It's called as the subgeostrophic condition. You want to read up something? You have one write up as gradient winds in page number 90. In page number 90. So that takes care of how are geostrophic winds formed and the modification for geostrophic conditions.